like okay, so that's how it will be exponentially faster compared to classical. So if the number of qubits are increased automatically, its efficiency will be increased to the next level. So this is the way how the research is going on quantum computation and also in development of quantum systems with a huge number of qubits. And first of all, let me tell you like what are the available quantum computers we have, because you can use any of the the free source, or the most of these systems are giving the pay and use possibility also for their quantum cloud. So you can make use of that for developing your or implementing your what we say architectures in any of the area or in any of the application, and you can run it on any of the available quantum computers, and you can see how it is working. So we have the available quantum computers. One is provided by the IBM. So we can get the details of that by using the quantum experience, IBM Q experience we have. So which is what I've shown you in I think second session. So where we have seen a platform with the drag and drop representation, right? So that is the platform where you can see available quantum systems of IBM. And apart from IBM, Google also having their own quantum system. We'll call it as a Sycamore. So usually it is a processor name. So even I think if you are aware of even yesterday or day before yesterday, we got a news saying that Google has been done one experiment. We can say it as a verifiable, like quantum verifiable experiment has been done, and they have been proven that, that experiment has been proven that quantum computer is 13,000 times faster than the classical computer in performing one operation. So what is that operation? I'll explain you in coming slide. So like how even Google is working on, even I told you in the 2016, like even they only done the experiment using the Shor's algorithm. They could able to break 128-bit like RSA algorithm using in just 200 seconds. So that is also one breakthrough at that time, and even they come up with the one more breakthrough just 2 days back. I mean, a day before yesterday. So it is like even with the same, like if they continue the experiments in future, we can also see more what to say more breakthroughs in various areas also. And apart from that, we also have the QTech Academy. So even they also have the quantum computer. The name of that is Quantum Inspire. And apart from that, we also have the D-Wave. So as I told you, Quantum Annealer computer they have. Okay, so the name of that is Ocean. And even Microsoft also have the quantum computer. And I mean to develop, like we have a Microsoft quantum computer. The name is, and Q Sharp can be used for developing the like programming language, and also the name of that particular quantum computer. And apart from that, even Amazon also have the quantum computer, where they are also providing the same like IBM and Google, like pay and use possibility. We can even purchase the cloud Amazon Web Services, like the quantum cloud, and you can make use of that for running the experiments. And apart from that, if we talk about, like, these are all foreign-based companies. But if we talk about Indian-based company, so QPI is the first company, and which has been developed as first quantum computer. The name they made the name as QVidya. So before, like, it is a 8-bit computer, and they are planning to like deploy that in Quantum Valley, Andhra Pradesh Quantum Valley. But apart from that, we also had like they also implemented 25 qubit quantum system like few months back, and now they came up with the 8-bit quantum computer, 8-qubit quantum computer, which they named as QVidya. And they are also planning to develop a quantum supremacy center in Bangalore. So even the work is going on. So this will be our first India quantum computer, which has been developed by the QPI AI. So at present, they are not giving the cloud access, but in future, they may also provide the cloud access as other companies are providing. And apart from that, like even the many other companies, if we talk about the startups, QM Labs and all, they are also working on the quantum experiments. But if we talk about the quantum computer, so these are the available quantum computers, and this is the India's first quantum computer. Even IIT Madras, they are also working on developing the quantum computer. So still, like many universities, many startups also working on in developing the quantum computer, even in India also. Okay, so apart from that, we also have like IBM's, like as I told you, IBM is also working on 4096, but at present they have the highest number of qubit system, that is 1121 superconducting qubits. So the name of that, like the processor name they have given is Condor. And now they are working on 4096. If that comes come into existence, even we can see more like even efficient results, and we can even break many existing algorithms, and we can also use that for the many applications for the better results. So this is what about the available quantum computers. But apart from this, we also have many other quantum computers which are there worldwide. Okay. So now even I was like I told about D-wave quantum annealer, right? So this is how it looks like. So the annealer, so where they have been used this equipment. So this entire thing we can the dilution refrigerator, we'll call it as this entire representation. And even in this, they will be using qubit generation. So there will be different representation or different materials that have been used. And apart from that, we also have a quantum computer. Like this is a representation of a quantum computer with superconducting qubit representation. So here, this representation contains various parts, like as we have in the classical computer, we have the control unit, processor, and arithmetic logic unit, and buses, data bus, address bus, all these things, right? In quantum also, like in quantum computer also, we have different, like quantum data plane we have. So this is like a quantum data plane is like a heart of the quantum system. Like without that data plane, we cannot do any operations. If we wanted to transmit qubits to perform any operation, then we need to transmit that through the quantum data plane. Okay. Apart from that, we also have the quantum measurement and also quantum control and measurement plane. So where the operations will be controlled and measured by the quantum system. And even we also have a quantum processor. So if you see, so this is where a quantum processor will be represented. Like this is the representation of quantum processor, and this entire architecture will call it as a will be represented in dilution refrigerator. So this superconducting quantum computer we cannot keep in our room temperature. As I told you, this will be performed by using the qubits which are generated from the photon particles, right? So if I wanted to keep it in, like if I perform operations in room temperature, obviously the photon particle will make more noise because it will be stable only in like if you wanted to perform the operations on photon particle, we have to make it stable first, right? To make it stable, we need to keep or we need to perform the experiments at minus 275 degrees centigrade. So that is what the temperature required to perform the operations on superconducting quantum computer. But for annealers and all, and even as I told you, like spin computers also we have, because most of the even academia they started by purchasing spin qubit system. So where we will be having the spin qubits, those can be operated at room temperature. But that spin qubit, like how it is reacting to the operations, that also different and compared to the supercomputer. Sorry, superconducting. So this is what a superconducting quantum system looks like, and it will be having various like hardware representation or hardware architecture along with the quantum data plane, quantum processor, and quantum control and measurement planes. And also this is where a processor will be represented, and this has to be kept in minus 275 degrees centigrade. So otherwise we cannot operate with the like photon particles. It will make it will generate more noise. Even in minus 275 degrees centigrade also it is making some noise, like it is generating some noise, which is again leading to the errors, right? If you reduce or if you change the noise level, like if you change the like temperature, and if we increase that to the some other value, then automatically there will be more noise levels, and that again leads to the more errors. So this is what like a quantum hardware looks like, and how it will perform operations on like based on our requirement. Okay. And now we'll see the applications. So let me give a brief about what are the applications we have, and then we'll discuss about each and every application in detail. So one application here we have is artificial intelligence and machine learning. So we can apply quantum computing and AI and machine learning. So even in QML we have been discussed. The QML will perform the operations exponentially faster compared to classical machine learning, and we also have when you have a larger data sets, you can make use of quantum machine learning to perform the operations. And apart from that, we also have one more application, that is computational chemistry. Sorry. So computational chemistry. So now a lot of research is going on in computational chemistry. We have a separate journal called quantum chemistry. So which is Q1 SCA journal. Even if any of you are working on chemistry and any of you are developing any novel algorithms for quantum chemistry, then you try communicating your paper to quantum chemistry journal. So there I mean, the possibility is a lot, like because even on quantum chemistry, like on even in chemistry, you can show the results, the difference between the classical experiments and quantum experiments. And apart from that, we also have the applications in healthcare, drug design, and development. So in healthcare, if you wanted to, like, at present, a lot of work is going on in healthcare using machine learning and deep learning. So at the same time, we can also apply, in place of machine learning, we can also apply the quantum machine learning. So where we can see the better accurate results than the classical machine learning. But at present, the only challenge is making the large data, because for few health issues, we are not even getting the sufficient data for the deep learning, right? So in such cases, how to make the data in larger sizes, and then only you can apply it on quantum machine learning. I mean, for the better results with the smaller data set also you can do. But if you wanted to see the better results than the classical one, then you can go with the larger data set. So in healthcare, major challenges finding the data sets of the larger size for the there are data sets available for the few problems, but there are also few problems where we doesn't have much data. And apart from that, we also have the drug design and development, where we can apply the quantum computing. So I think every one of you are aware, like whenever we'll get the new medicine, so to find that new medicine or new combination, they will perform the operations on various molecule combinations, right? For example, we have I wanted to develop a drug where I need to perform the operations on, let us say, some 10 molecules, right? So using 10 molecules, there can be a combination of 2 part 10 possible combinations, right? So by using quantum, you can perform all those possible combinations, you can develop all those possible combinations, and you can find out the efficient one in less time when compared to the classical. So this is how a quantum plays a very important role in new drug design. And also it has been proven, now people also working on in quantum like working on drug design using quantum technology. And then one of the important application we have is cyber security and cryptography. Already most of the people started working on in quantum cryptography. So because you can apply quantum technology as security basically. Yeah, because as I told you, if quantum system come into existence, the first problem will occur on the security. So it can be defense, or if you talk about if you talk about our bank credentials or like whatever the credentials, all those are secured by the various security protocols. But algorithm has been proven that the quantum system can easily break the security protocols because it can easily find the integer like it can easily find the integer it can do the integer factorization where it can find the prime factors. So with that, we can break any security protocol, either the RSA, AES, or ECC. We have many security protocols, right? So that's why, like now, a lot of work is going on in quantum cryptography. Even if any of you are interested in starting your journey in quantum, I suggest you to concentrate on security part also, because there is a lot of scope and there is a lot of opportunity. So you can even in security also we have some various subdomains where you can concentrate on. And apart from that, we also have the applications in financial modeling. So when we wanted to minimize the portfolio optimization, or so when we wanted to, like for example, we can also apply prediction, right? So even with the like mechanical principles, like we can even predict the stocks more accurately than what classical machine learning is doing. And apart from that, you can also apply it on logistic optimization. So if you wanted to find like an accurate route from one place to another place, then you can even apply quantum machine learning on that. Because here at present we are also using Google Maps, like where we have been applied quantum optimization, sorry, classical optimization techniques. But here the problem we have come across is, for example, if I let us say delivery boy wants to deliver need to deliver some order from some to some location, let us say. So he is about to reach the location, but in between sudden hurdles have occurred. Like let us say some accident happened, or there are some complex hurdles, which like in such cases the accuracy of the classical optimization techniques are less. It takes time to understand that problem and also to give the another alternative solution, like another alternative path, so that it can reach in time, right? In such cases, you can use the quantum computing, like quantum optimization techniques you can apply, where it can find out, like it can react and it can show the all possible paths like within a less time, and so that it can find out the even from those all possible paths, it can find out the nearest one, so that you can reach to the destination in time, Okay, this is how a quantum computation and quantum optimization techniques are uh, currently being used in various applications. Even the research is going on in this area also. And we can also apply it on weather forecasting. So as you are aware that weather forecasting is one of the tedious job. Like even we are seeing a lot of uh, lot of updates on weather, but sometimes it works correctly and sometimes it may not work correctly. So there is the accuracy may not be 100% every time, right? In such cases, to get the higher accuracy and to predict the weather efficiently, we can apply the quantum technology in weather forecasting also. But apart from that, we have one more application, that is teleportation. Like quantum can be used in teleportation. It can be human teleportation or it can be any animal teleportation. So teleporting, as of now we are teleporting the data from one place to another place. So that teleportation is like we are doing it on qubits. Like the qubits, if I wanted to transmit from one place to another place, I can use the quantum teleportation process, and where I can transmit the data through the quantum channel. But apart from that, we can also teleport the humans from one place to another place. This is how it looks like. So this figure is an example for the quantum teleportation. So like research is going on. So but this may happen, like in future this may also happen. Even a human can be here, and next moment they can be anywhere in the world. So that also be possible with the quantum principles. Like even with the research, even in coming years we may see this human teleportation also. So these are the applications. So apart from this, as I told you, on the areas on which you can apply the machine learning, on same areas you can also apply the quantum machine learning. So same domains or same applications you can use for applying quantum machine learning. Even you can compare the classical machine learning outcome and quantum machine learning outcome in such cases. So now we'll see in detail about the quantum computing and artificial intelligence. So here I'll just tell you how artificial, because we have discussed about quantum machine learning and what are the companies are working on, like what kind of problems in quantum machine learning. Okay. Yeah. So here, we all know that quantum machine learning will outperform the classical machine learning in it can be used in various applications, like to accelerate optimization or to perform the data encoding and for the pattern recognition, and in various applications we can use it. And here the major advantages, like usually when the data size is too high are too large, then it is difficult or it takes a lot of time for the classical machine learning to train and test the data. And also to apply the model, it takes a lot of time for running. And based on the epochs, for example, if the number of epochs are more, again, it takes a lot of time, right? So in such cases, you can alternatively use the quantum machine learning. Even it predicts the data, like it gives the high accuracy, and also it will train and test the data in less time. And also uh, like and also it takes less time for running the model. And here even you can use the same number of epochs, or we'll call it as the shots here. So with that you can get the results when comparatively in less time with the better accuracy. Okay. So here the major advantage here is, like as I told you, so for example in classical, if you have the data, then that will be mapped to the high dimensional feature space, but here we are mapping that to the high dimensional Hilbert space. So that will be uh, different, and that will be done naturally by applying the data encoding technique. So if I apply the unitary operation on the classical data, then that will be converted into quantum data, and then I can apply the rotational gates and also C0 gates for performing, or to make to represent that on feature map and to perform the operations on quantum information, right? So at present, like there are various algorithms like quantum SVM, quantum neural networks, VQA, like many application like algorithms have been designed to perform the operations on complex problems. As I told you, one example is handling the chat GPT data. So if I wanted to handle, or if I wanted to process one chat GPT data, that is difficult for the classical computers, right? In such cases, you can apply the quantum machine learning algorithms. And similarly, like where you have the huge data and it is little bit complex for the classical machine learning algorithms to perform, then you can use the quantum machine learning instead. And at present, the companies like IBM along with the MIT, so they collaboratively working on quantum neural networks, and they also applied it on various applications. At present, like even they worked on the complex data set like handwriting digits, like handwritten digit, because it is like people will write digits in a different ways, right? So this is one of the complex data set, and processing this and converting that into text will be a little bit challenging. So even they're working on this, like they are applying quantum neural networks for this. So even there's still research is going on in this area, and also they're working on the materials. Like we have the quantum material, like normal materials. So even to process the data of the materials, also they are using the quantum, like quantum machine learning algorithms. Apart from the IBM, Google also working on quantum AI. So Google is working with the QA algorithm, which is used for, like usually it will be used for training reinforcement learning models. So it has applications in various, like if you have any application where you need to do the optimization techniques, then you can apply the like QA, and Google is presently working on that. Even as I told you, like they have because the like day before yesterday news has been published, and they came up with the variational like verifiable algorithm. So it has been verified, and what they worked on is like they worked on the like atom or molecule level. So if you wanted to find out molecules in a particular atom, so it will be difficult if the number of atoms are more. Then finding the molecules and all the structures will be difficult for the classical computers. But that has been done by the quantum computer, and it is 13,000 times faster when compared. So it has been verified. So it has been proven. So that's why we are calling it as a quantum, a verifiable algorithm. So which has been proven by the Google's quantum computer. The name of that is Echos, quantum echoes. So they have been used their quantum system to perform that operation. So apart from that, we also have one more quantum computer called Quantinum, which has been developed by the like Cambridge quantum like team. So they are also working on natural language processing. So they are working on applying the quantum technology and natural language processing, and they have been developed, and they are applying this on various applications now. So this is how the work in artificial intelligence along with the quantum computing is going on. So these are some examples. So I've been just taken only the leading quantum industries. But apart from that, many people are working in this. So as I told you, our like Indian based company, so Cupa AI. So they are also working on quantum AI. So they're most of the applications are related to the quantum AI. They are completely concentrating on quantum computing and quantum machine learning and quantum AI. So this is where like even like similarly like QPIA, many other Indian startups also working on quantum machine learning. Apart from that, many foreign countries also working on quantum machine learning. So like if we see in last 2 or 3 years, there have been many startup companies which have been started in this quantum technologies, and they are working good. Like even their outcomes are comparatively good. So similarly, like there is a lot of scope in these areas. If any of you are interested, you can look into this and you can continue your work. Continue your work. Your work. Okay. So this is about quantum computing and artificial intelligence. So along with some examples how the companies are working on this. And next we'll see quantum computing in drug discovery. So one of the major application we have is that drug discovery, and even the quantum principles will give effective results in drug discovery. Like if you wanted to develop a new drug, and also if you wanted to discover any new molecule structure in drug to develop a drug, we can apply the quantum technology. So usually, like we will be like when we are talking about the drug discovery or drug design, so it will be a combination of various molecules and molecule interactions. As I told you, for example, if I have a like let us say we have some 100 molecules, okay, I have to use or I have to develop a drug using these 100 molecules. Then using 100 molecules like those I can combine in a different ways. So total there will be 2 per 100 possible ways with which can be used to combine all these moleculars, right? So in those 2 per 100, which one is efficient? So if it is working good on that particular problem, then only it will be used and will be issued for that particular like will be I mean used in society for that particular problem, right? So finding one effective molecule combination from 2 per 100 will be not possible. Like it is complex and also very difficult for the classical computers to do. But whereas in quantum computer, we can do that with the 100 qubits, like we can have all possible combinations, like using the superposition, we can perform all 2/100 combinations. And within less time, we can find out the effective one and we can use that for the drug design. So this is how it will be useful in drug discovery. And now, as I told you, like many, we have pharma companies, right? So many pharma companies are working to combine quantum with the existing algorithms like for drug design and all. So it is even showing very good results in drug discovery. And at present, if we talk about the companies, IBM is working with the Cleveland Clinic. So there they are working on the biomolecules and proteins. So they are modeling those like the biomolecules and protein combinations. And for that, actually, they are applying the VQE. So we have been discussed VQA, right? So that we will use the eigensolver, call it as a VQE. And these will be used for, like, usually when we talk about the molecules or proteins, we need to concentrate on the ground state energy. So those ground state energy things will be calculated by using this VQE and VQA. So even when we discussed about VQA, I just told it will be used in ground state energy calculation, right? So that will be that is very important in drug design. So that is one of the advantage in quantum that we can apply on drug design, and we can even find the effective drugs even for the, like for any of the, like, because now even we are coming across very like new diseases also, right? After COVID, we could able to see many new diseases which we haven't seen before that. So even for those new designs also, sorry, new diseases also, if you wanted to design a new drug, then we can use the VQE and quantum measurement algorithms for finding the results more accurately in less time. Okay. And also, like Pfizer and IBM Quantum, they are also working on simulating the chemical reactions. So there will be, like, even in chemical or chemical industries, so they will find out the new chemical combinations by doing combining or simulating multiple chemical combinations, right? So, like, how these combinations will work and how to bind all these combinations, all those can be done using the can be done easily by using the quantum technology. And apart from that, we also have Menton AI, where they are like using quantum AI for designing the drugs. So usually they are concentrating on peptide drugs, which will be used for the biotechnology. Okay, and they are using quantum annealers actually. So till now, here IBM is using their superconducting quantum computer, but Menton AI is using quantum annealer. So they are associated with the D-Wave system. So they're using this for designing the peptide drugs using the quantum AI. And apart from that, we also have the Accenture. Accenture also working on quantum like working on quantum technology. They are applying it in molecular comparison. So even they are also collaborated with the Biogen and also one qubit. So these three are collaboratively working on molecular comparison. Like there will be multiple moleculars, how this will be used for reproducing various drugs. All this like research is going on in their collaborated project, which is quantum based molecular comparison. So this is what the research is going on in drug discovery throughout the world. And these are, like, as I told you, I'm just giving a brief about how the companies are working in these areas. So based on that, you can think where you can concentrate if you wanted to apply quantum in your in drug discovery. If any of you are interested in work in that particular area, you can concentrate on all these possibilities. Like you can even work at molecule level, or you can work at chemical like combining the or binding the chemicals, or you can even work at designing the various drugs, because even drugs can be used for the various applications, various problems, right? So you can concentrate on that. Even you can develop the solutions by using various quantum computers, like superconducting or ion based or trapped ion, or like even annealers. So you can use any of the system, but based on your requirements, so what exactly you wanted to get as an outcome, you need to be clear with that first of all, and then only you can apply the quantum principles on what of the classical data we are giving, and then you can even write an algorithm, or you have to design a model which will give the expected outcome. So this is these are applications of quantum computing in drug discovery. And now we'll see the applications of quantum computing in finance. So finance, like we have lot many applications in finance, because at present even people are working on that, and most of the people are working in stock prediction and optimization and to analyze the risk, because most of the people are investing in various mutual funds and all, right? So they are investing in various resources or in various sources. So what are the risk, like the analysis of the risk in various sources, like all this can be done more accurately than classical machine learning models by using the quantum. And also we can work on the pricing, like how the prices will be, because if you see the gold market, so till 2 or 3 days back, it was around 1,34,000, right? But now, if you see it reduced to, I think, 1,24,000. So there is a 10,000 difference only in 2 days, not even in 2 days. Yesterday it was like day before yesterday, 2 days, let us say. So if someone has invested on gold when the price was 1,34,000, so within 2 days they lost 10,000, right? So similarly, how this deviations will be done, how pricing will increase or decrease. So it is again associated with the like real world things, like what is happening in the worldwide. Like if any, let us say, if any war is happening in any country, that also affects the pricing things. So we can use the quantum computing or quantum technology to like to predict the prices by considering all these possibilities, by taking, even it can go through the like if we talk about, like if we see the 10 years back data, then if we compare that, we may even predict the current, like how it will be, whether it will continuously increases or decreases, that also we can predict. So for such kind of data, because they are 10 years, or like if we take larger amount of data, then automatically processing will take a lot of time. So in such cases, you can apply the quantum computing even for the fraud detection. So now fraudulent effects are happening in everywhere. Like even most of we are using digital digital transactions. Like most of we are having digital apps for the transactions. So I mean, there are a lot of frauds are happening based on that. Even, and not only in that, like frauds are happening everywhere. So if you wanted to detect those with more accuracy, then we can go with the quantum computing. You can try to apply quantum machine learning models, and then if you like even I mean after applying, you can even compare the classical machine learning and quantum machine learning, and you can see how exactly it is working and how accurately it is showing the results. Okay. And apart from that, it is also used for accelerating Monte Carlo simulations, because in most of the application, like we will be having Monte Carlo simulation. If we talk about electronics or electrical, like even mechanical people, they'll do these simulations, right? So to accelerate this, because usually these simulations will work good, but to make it more faster or to make it more accurate, we can use the quantum computing. We can associate this with the quantum computing, and then we can see the better results than what we are seeing today. And apart from that, this can also be used in optimization problems and also in pattern recognition. So these are some examples of finance where you can concentrate on applying the quantum computing. So if we talk about the companies which are currently working on R, so one is JP Morgan and IBM. They are collaboratively working on quantum amplitude estimation. So as I told you, to speed up the Monte Carlo simulation. So they are using this quantum amplitude estimation for this speeding up the simulations, and they are applying this mainly on the pricing. So to find the optimization, or like to predict the pricing and all. Okay. At the same time, like Goldman Sachs and QC, where they are also working on they are also applying quantum algorithms. Like we have the optimization algorithm, right? QAOA. They're applying that for the portfolio optimization. So they are at present working with the quantum annealing computer. So even they have been associated with the T-Wave. So they're working with that on portfolio optimization. And next, even we have the Volkswagen and D-Wave. They're combinedly working on traffic flow and logistic optimization using D-Wave's quantum annealing computer. Okay. And apart from that, even HSBC and Quantum, because this Quantum is based like Cambridge-based like quantum system. So they are working on quantum natural language processing for analyzing the various financial documents. So HSBC is bank we have, right? So they're using this for analyzing the documents and how the financial things will be, and even to analyze the various contracts more effectively using the quantum technology. So this is these are the some applications of the finance. So apart from this, like we have lot many applications, and also lot of the companies are working on in finance based applications. Okay. So any doubts still here? So if you have any doubts, you can you can ask me, because I hope most of the people are working in these areas. So if not, I'll just continue. Okay. So apart from this, we also have the applications in cryptography. So as I told, the major area which we can concentrate is cryptography. So applying quantum computing in cryptography will give enormous results than the classical cryptography. So here, as I told you, once the quantum systems come into existence, the classical crypto systems or security systems will not be secure anymore, because all those are mostly, depending on integer factorization and prime factor calculation, right? So with the quantum system, we can find those easily using the Shard's algorithm, and we can break those the existing quantum or security schemes. So to strengthen that, we need to either, like here, there are two research possibilities. One, you can concentrate on quantum cryptography. One, you can concentrate on post-quantum cryptography. So, there is actually a difference. Post-quantum is different and quantum cryptography is different. So now research is going on in both the areas. So what I was telling here is, once the quantum systems come into existence, whatever the security schemes we have or security protocols we have at present, classical security protocols, will be in trouble, and we can easily break those, right? So, for example, I developed one security protocol, let us say, but what the research is saying is that, it has been proven also, if Shah's algorithm can easily break my security protocol. So what I can do is, like, I can strengthen my security protocol, whatever I have been developed in a classical perspective. So I will strengthen that by applying the quantum principles. For example, let us say RSA algorithm. So this has been developed by considering the classical perspective. So at present, 2048 RSA algorithm is one of the strongest algorithm. Even supercomputer will take some thousands of years to break that. So that's why in most of the security protocols, we are using that RSA 2048. But with the 4096 qubit quantum system, we can easily break that. So to overcome that, what I can do is, whatever the RSA 2048 algorithm I've been developed, I'll just make it as a quantum safe. That means I will convert this, like mathematical modeling, whatever I have done, I'll convert that into quantum safe by applying the quantum principles. So even after applying the after the existence of quantum system, it cannot be possible for that to break, because at present RSA we have been developed with the classical computing or classical bits, so that we are unable to break that using the classical computer. If I make it into quantum, like if I apply quantum principles and I will make it into a quantum safer, then automatically if I apply the quantum computer also, I may not break that particular algorithm, right? So this is what a post-quantum cryptography is: converting classical schemes into quantum safe by applying quantum principles like superposition and entanglement. We are applying that, so that the mathematically we are just modifying the algorithms, and we are checking how fastly it is working. So for the post quantum cryptography experiments, or if you wanted to do the research in this area for the experimentation purpose, there is no the quantum system is not required here. In post quantum cryptography, you will do the operations only in the classical system. So even you will modify the existing classical security algorithm into quantum safe, and they will mint only. For this, there is no, what about post quantum cryptography? And apart from that, we also have the quantum cryptography, where we need to develop the quantum cryptography algorithms to to make the quantum system secure, right? Even so, that is where. So in quantum cryptography, the entire operations will be performed in quantum environment only. So you need to use the quantum system to simulate and run your experiments. Okay, so this is what difference between post-quantum and quantum cryptography. And at present, IBM is working on almost all the areas of all the areas, and they are applying quantum computation in almost all the domains. And apart from this, the Indian-based company, startup company, QN Labs, also working on quantum cryptography, quantum communication. So they even develop the quantum key distribution equipment, and even they have a lot of projects from the Indian government, mainly from the defense, to make it quantum safe, to convert it into quantum safe. Because as I told you, when the quantum system come into existence, first of all, they can easily break the security protocols, right? If that would have done, then automatically all our defense will be will depends on the security based schemes, no? So those can easily breakable. So for that reason, government is currently concentrating more on making all defense security systems into quantum safe. So for that, the company along with various other collaborators, they are working on like strengthening the security. Even if the quantum system come into existence, that will not be that will not break these quantum safer algorithms. Okay. So this is what post-quantum cryptography or post-quantum algorithms are. So at present, as I told you, we have all these classical algorithms, so names of symmetric and cryptographic algorithms, which I have already, and we're working on this, right? But with the if for example, at present these are all secured. But in quantum, like if the quantum computer come into existence, then we can easily break all this. The first algorithms are easily breakable by the Grover's algorithm, and second is easily breakable by the Short's algorithm. So for that, what you can do is you can convert this into quantum safer. You just apply quantum mechanical principles, and you just convert this into, like, you do the mathematical modeling and convert this into quantum safer, so that even if quantum system is used, or even if Shor's algorithm is applied, that should not be breakable. So this is where you can concentrate on. And for post-quantum cryptography or post-quantum algorithm design, you can develop and simulate and run that in classical platform only. Classical environment will be sufficient. For this, no quantum is required. So this is about the post-quantum algorithms and the difference between quantum cryptography and post-quantum cryptography. And even the other applications we have using quantum technology are secure communication and climate modeling and sustainability. So secure communication, as I told you, so for example, if we wanted to transfer the data from one place to another place, it is not what you say, like any third person can try to hack the data or can try to observe the data, because it can be hackable. A classical data can be hackable, but a quantum data cannot be hackable, because if any third party try to read the data, then automatically we are just disturbing actual state of the quantum computer, right? One second. Yeah. So if any third party tries to read the data, that means it will be tries to read the data, then it can be easily known by the quantum, like quantum computing, or in terms of quantum computing. For example, let us say, for that, actually, you need to know, or you need to be aware of quantum key distribution process. How this process will be done is, for example, we have the Alice and we have the Bob, and I'll transmit the data from Alice to Bob through some quantum channel, right? This is Alice, let us say, and this is Bob. So I will transmit the data from Alice to Bob, and if we use the classical data transmission, if I use any classical bit, any third party, let us say, you can easily observe the data. It is possible, right? Even they can manipulate the data, or even they can even simply modify the data. So that is possible with the various techniques that hackers are using now. But apart from that, for example, instead of this classical bits, if I transmit the qubits, okay, so I'm just transmitting the qubit from source to the destination, and to transmit these qubits, we need the separate representation or separate hardware requirement. So we need the polarization particles, and through the polarization particles, I'll transmit the data from source to the destination. So while transmitting, we need the quantum channel. First of all, this data will be transmitted through the quantum channel, which supports the transmission of quantum states. Okay. So while transmitting, if any third party tries to read the data, so tries to read the data, or trying to observe the data, means we are trying to measure the data, right? So when we try to measure the quantum data, that means we are disturbing it. So that is what superposition is saying. So I told you the example of flipping a coin, right? When you flip a coin, it will be in both the states. So that is a superposition. But when I wanted to measure it, I'm just disturbing its state. I'm just seeing whether it is heads or tails. But how I'm seeing that by this disturbing its actual state, right? So for example, I've seen that it is heads. But if I do the same thing again, if I flip the coin again, next time it may not be heads, right? It may be tails or something. So that means the data will be, if I wanted to observe, the data will be disturbed and the actual state of a quantum bit will be modified. So that is what happens when a third party tries to read the data. So even though sender and receiver will do the data transmission, like quantum bit transmission between both, even if any third party tries to read the data, it can be possible by sender and receiver to find out someone is trying to observe our data so that they can cancel this transmission. So once they know that, they'll just cancel this transmission and again they'll start one new data transmission between sender and like sender and receiver. So even if that time, if any third person tries to read the data, again they'll get to know that. Otherwise, the data can be transmitted between Alice and Bob. So here there is a huge the like huge process. So here usually we will use the BB84 protocol for this. So we have the BB84 protocol, so which is used for performing the quantum key distribution from source to the destination. So even like so we are not concentrating on quantum key distribution now, but if any of you are interested in this, I suggest you to go to BB84 protocol. Like we have the data available in various papers which have been published, and the process is same. Sender and receiver will send the data through the quantum channel. If any third party tries to read the data, then it will get disturbed, and they too, like even sender and receiver, will will get to know that. Okay. So even apart from this, there will be a lot of representation. There will be polarization particles, even the process, how they will be detected. If any third party intervention, how they'll get to know. So there is a lot of process, huge process will be there. Okay. So if any of you are interested, you can even work on the secure communication by applying the quantum technology. So one of the main uses quantum key distribution. So at present, quantum key is unhackable, and also like even if any third party will try to, like hacking means it's like reading the data or observing the data, right? So at present it is unhackable. So we can't say that in future the people may come with new solutions, or like even hackers also talented. So they come up with new solutions. But even though like as per the principles or the uh, like principles of a qubit, like as per the behavior of a photon particle, if anyone tries to read the data, automatically it will be lost into some or the other state. So where the actual state will get disturbed. So and even we also have the no cloning theorem. So even we cannot copy. If anyone tries to copy the data, that also not possible due to the no cloning theorem. So even to copy the data, that means we are trying to read the data, right? We are trying to measure the data. So once you try to measure the data, then automatically it will be lost into some other state. So where the actual state will get disturbed. Okay. So this is where you can also concentrate on. And apart from that, we also have the one more application, climate modeling and sustainability. So where like same as I told you, like weather forecasting, or if you wanted to predict the climate, how it will be, and if you wanted to predict the weather patterns based on the previous data, or if you wanted to analyze the effects of a climate, even like any of that, like if any of the application, if you wanted to uh, get the high accurate results, or like if the results need to be highly predictive, then you can apply the quantum technology on that. You can use the quantum simulators for to run your experiments on quantum platform. And apart from this can also be used like even it can also predict like any, even if you see tsunami and all, no, even those can also be predicted more accurately by using the quantum technology. So these are the applications where you can concentrate on like applying quantum technology for the development of the operations, or to get the better results than the classical computation. Okay. So any other doubts till here? Because this is completely on the applications we have been seeing. So apart from this, we have many other applications, as I told you, where you can apply the quantum computation. On those applications, you can also apply the quantum like classical computation wherever you can apply. So on the same on
నేను
same
చాలా
process,
తక్కువ
you
తింటున్నాను.
can also apply the quantum computation. Yeah. Any doubts, ma'am? Okay, so this is where you can concentrate on, and these are the applications we have with the quantum technology. And now coming to the leading research institutions, because as if you are a student, like if because students also attending this session, so even if any MTech student wants to do the PhD in quantum technology, you can even look into these institutions, which are where the quantum research is going on, and they have some dedicated quantum labs with the practical equipment. So even you will get the practical knowledge when you work on those equipment. Even apart from that, even in India also we have the Raman Research Institute where the lot of research is going on in quantum physics. So they have the equipment related to the quantum physics where they are generating the qubits using various like polarization particles, and even they will show you how
Excuse me,
superposition
madam,
will
I have one doubt.
develop.
Can I
Yeah, sir.
express?
Yeah,
Suppose
yeah, sure, sir.
nowadays neurological problems are being cropped up. So how far is
Okay.
this quantum computing in collaboration with AI like deep learning and IoT is going to
Mm.
help resolve such kind of new kind of neurological problems that are cropping up?
It will be very helpful, sir, because neurological problems actually are complex problems which will be difficult even for the classical machine learning models to even predict the problems, right? So, because neurons means there will be a lot of things we need to concentrate on, and predicting the problem will be a little bit complex. I can't say that it is impossible, but it is a little bit complex. In such cases, if you apply the quantum, no, as I told you, even if you have the large data and if the data is also complex, it is easily predict or if we can easily analyze that using the quantum principles, like by applying the superposition and all. So even if the data is of too large, and if we have a lot of even a lot of let us say, I think, I mean, recently we have come across one solution for the quantum neurological issue. So we have actually one of my senior, he was done in the neurological issue using classical machine learning, but he's also working he's also willing to apply quantum machine learning on that. So we have taken a small data set for the neurological issue.
Okay.
Neurological issues, we have some various issues like varicose vein issue. Currently, a lot of people are getting, right. And apart
Yeah.
from that, we also have I mean, many people even brain due to some
Yeah.
I mean, yeah, so they are affected by the some neurons, and many people are just losing their memory. So even this also have been seen across, like even in my nearby places in and also in the society. So on that, they have been taken one small data set. So they have been
Okay.
applied quantum machine learning and also the classical machine learning on the same data set. So that is one of the
Okay.
complex data set where we had a lot of parameters which were complex to even because the model was also designed in that way, because to detect some particular neuron based problem, they need to come across with the various parameters. They have to analyze all the parameters and then they have to give the answer, right? So in such
Yes.
cases, in such case, quantum machine learning has been given very good result compared to the classical one. So it has been proven, sir.
Okay, madam.
You try applying that on any neuron based disease data set. If you have, you just try, because here the
Madam,
problem
there
is
is
finding the data set.
actually. uh,
Yes, sir.
Yes, madam. That is the what I am very difficult in finding the data set because there
Correct.
are it
Yeah.
is the it is a brain related problem. It is more than
Okay.
forgettingness. It's more than
Yeah.
Alzheimer's disease. It's more than dementia. It is further
Uh,
more than it is a new disease that is cropping up. It
mm,
affects one person, maybe 10 out of 1 lakh. In 1 lakh, 10 people will get that kind of disease, and
correct.
sometimes they get they could recollect whatever the memories they have, but sometime most of the time they couldn't even recognize their own daughter, son, or their own
Correct.
blood
Correct.
relations.
Yeah, true, sir. Even I come across with the same situation. I've seen one person who is affected by that. So the
Yeah,
problem here is, even in the test, they could not able to find anything. Even if you do the CT scan or MRI, so in that scanning,
yeah,
nothing has nothing it
yeah.
is
Yes,
showing.
madam.
Like
Yes,
everything
madam.
is fine. But
Yes, madam.
something, because they are having the issue. Even in Alzheimer's and all, will get at least some. I mean, they'll get to know. Okay, due to the some issues, they could be able to, they are unable to recall the memory. But in such cases, it is not Alzheimer or anything, but but even they're not finding the people, or even it is almost like more than Alzheimer's, like what you have said.
Yes,
So
madam.
it is
Yes, madam.
also happening, but for this at present the problem is we don't have any input, because if we have any reports that I can take as
Yeah.
a I mean that I can take, and based on that I can process it. But for this we don't
Okay.
have any. Yeah, even they have done like scannings in various places. Almost they have covered entire India, like good medical institutions around the India, even hospitals and all. But they could
Yes,
not
madam.
able to find anything. Everyone saying that nothing. Yeah. So this
Yes,
is
madam.
one of the problem where we may feel difficulty, but you can concentrate on Alzheimer's. So even for finding the Alzheimer's and also for predicting that, it requires a lot of parameters. It has to process a lot of parameters, and based on that it has to give the outcome. So even
Okay.
for that the classical machine learning will be little bit like feel little bit complex. So you can
Okay,
apply
madam.
quantum machine learning on it, because on that you have some data sets. But as I
Okay,
told
madam.
you, for many other neurological
టమాటా
problems
అది
we don't have
ఏమైంది
the
కదా
data set.
కొద్దిగా అవుతుంది.
Okay, madam. Madam,
So
where
one
can I find
suggestion from,
most of the data sets, madam, related to clinical, these kind of problems?
yeah, that only I was suggesting. So if you wanted to do in this way, you try to collaborate with some hospitals. So where like we have neurological specialists, right? So they have some
Yeah.
specialized hospitals. So you
Yes,
try
madam.
to collaborate with them, because these are all sensitive data. So usually they'll
Okay,
not
madam.
give it to everyone. So if you
Okay, madam.
collaborate with them and you will say that like I'm planning to develop a model on that, if you could able to give the data, so we can collaborate in that way. We can even help you in automating the things and all. You can think in that way. So
Okay.
because we don't have any other option. These data we cannot even find, or we cannot even generate, right?
Okay, madam. Okay,
Until
madam.
until we have, yeah. So you try to collaborate with some hospitals, sir.
Okay, madam. Thank you, madam. Thank you for your information, madam.
Okay, okay, sir. So these are the leading research institutions. So even in our India, as I told you, we have RRI, Raman Research Institute. So this is fully, they are working on satellite-based quantum communication and quantum physics. So quantum physics, they are mainly concentrating on. So if you are interested in developing qubits from the various materials, and if you wanted to work on qubit characteristics, then you can try applying to Raman Research Institute for the doctoral or MTech if you are interested. Okay. So apart from that, even many universities in India also having quantum as a PG program, and also in a PhD they are including. So like you can concentrate on, but these are some leading institutions where they have dedicated lab for quantum research. So where you can work on the practical equipment. Okay, so these are some certifications. So as I told you, so if you wanted to learn a quantum in detail, like and if you want to have the certification, you can even try off any of this certification. Even IBM is providing quantum developer certificate. So it is like in this few are free, and few are you need to pay the amount for the exam. So this developer certification exam is of $100. Okay. So for the other countries, there is some waive off also. So you have to pay the $100 and you have to write exam. If you get 75%, then only you'll get this certificate. Otherwise, your money gone and certificate also gone. So you need to be careful in such cases. And we also have the MIT Pro Quantum Computing certification. And even IIT is providing quantum computing certification. IIT Madras, IIT Roper, and many IITs, IIT Guwahati. So they started quantum computing certification, but this is also associated with the cost. So there is a cost for the certification. So there will be 6 months course, I guess. So they will be charging the amount. You just look into that. If you are okay with the content, and if you are okay with the cost things and all, you can even try registering that. And then we also have the certification programs which have been given by the companies like Microsoft and Google. Even apart from quantum developer certification, IBM also conducts a summer school. And even if you complete that summer school with the excellent performance, you'll get the excellence badge. So this in summer school there will be task. So we need to do some lab and all. So it will be not that easy. So if you could able to do, you'll get the excellence badge, and this will be useful for getting placed into quantum companies. So this will be like, and apart from that, even AWS and Google also providing some certification programs. So you can concentrate on any of this. So, like for example, if I wanted to say that I'm good in quantum or something, you need to have some proofs. So you can either publish the papers and complete some certifications, and even that will be helpful for you to continue your journey in this emerging technology. Okay. And next, we have the internship opportunities and also placement opportunities. So this is with respect to the students' perspective. So if any MTech students are good in quantum computation, and also even if any BTech students are good with the quantum basics and also good with the quantum programming, then you can try applying to any of those companies for the internship opportunities. So Google is seeking the internship the students for quantum AI. So they want the what we say research, or they want the human researchers who can work in quantum AI. And Microsoft also working on the cryptography and also quantum AI part. So if you are so every year they'll give the notification for the internships. Even IBM is working on many areas of the quantum, as I told you. So they are working on cryptography, machine learning, like quantum AI. So even quantum optimization, like quantum error correction. So they're covering almost fault tolerance quantum computers. So they are also working on developing that. So you can try applying to IBM quantum internships also. At present, the call is on. So I think recently they have been announced a call for the internship application in quantum computing, especially. So you can try checking or visiting IBM website, and they will find out. So I don't remember exactly when will be the last date, but recently I've seen one notification or a call for the internship by the IBM. So apart from that, we also have internship opportunities at QNO Labs and also QPI AI. So QNO Labs, they require the students who are good with the quantum communication, because as I told you, they are fully working on the quantum communication and quantum cryptography. So if any of you are interested in working, have a good knowledge on quantum computing and quantum communication and cryptography, try applying to QNO Labs. Even QNO Labs also give the internship, the notification for the internship every year. So usually all these companies will call the internships in summertime. Okay. So just try checking their websites, and if any opportunities are there, try applying to those companies. And if you get, you'll get you can work on their hardware equipment. So you will be having that opportunity. So you can work on hardware equipment, and even you can, like with that, even if your performance is good, then your internship may continue or will be what we converted as a full time. Okay, so you can even try in those. And also at present, many IITs and NITs are calling for the internship. So for the paid internship, they're paying some amount. So it depends on the project. So a lot of IITs and NITs are currently having the projects, quantum related projects, and for that they need the people who can work in that particular area. So for that, they will give the internship calls every year. I think twice in a year. So once in winter and once in a summer. So you can try applying for the internship in those times. Otherwise, you can go through the websites. So IITs and NIT websites, and you can check what are the internship opportunities are available. Because if they have the project and if they'll get any fund from the government, they obviously give a opportunity for the students to work in that, so that you can utilize and you can continue your work also. Okay. Apart from that, there are also various foreign universities which will give internship opportunities in remote mode. Like you can even work in online mode also. So just try finding, because most of the foreign universities are having their own quantum equipment. So you can try applying to those, and you can try working on that hardware equipment, so that you'll get the knowledge, and even based on your experience, you can either continue or you can even come up with the new algorithms. Okay, so there will be a lot of opportunity. And apart from that, many quantum startups, like when in India and also worldwide, there are a lot many quantum startups are there. So where you can concentrate on in doing quantum research. 1 second. you try to apply for the India. So like even in QNO labs, like as I told you, and apart from that, they did Bangalore and Delhi and to those companies. And if you get on their hardware equipment, or you can convert that internship opportunity as a full-time opportunity, even in companies, IITs and NITs. So these are some opportunities which we have. But apart from this, we have many other opportunities worldwide, which you can concentrate or which you can look into. Okay. So as I told you, in quantum, we have 4 verticals like quantum computing, quantum communication, quantum materials, and quantum sensing. So in these 4 verticals, we have the equal opportunity even for the internships and also for the placement. So yeah. Okay. So we have the equal opportunities. Okay, so quantum computing and communication, like mostly you can work with the, like you can develop the algorithms and all. But when we talk about quantum materials, you need to work on the material. As I told you, like we have the superconducting material, ion-based material, and the silicon-based material. So there are various types of materials that are present, and on that you can if you develop the qubits from these various materials, there will be the like different outcome, or you can work at the characteristic level. So all those you can work on, and even we have the quantum sensing. So they're also like, even if any of you are interested in sensing part, you can also concentrate on that. At present, the people who are working in quantum materials and quantum sensing are less. So you can even concentrate on those areas if you are interested. Okay. So apart from that, we also have the various research areas in quantum computing. So the first research area we have is quantum algorithms and complexity. Yeah. So in this quantum algorithms, like you can develop the algorithms for the various applications. If I talk about optimization problems, you can develop the algorithms for the quantum optimization, like optimization techniques. And you can also work on the complexity calculation using the quantum algorithms. And we also have a lot of opportunities quantum complexity theory. So where a lot of mathematical modeling will be associated with. So you can concentrate on this also if you are interested. Otherwise, you can also work on quantum error correction and fault tolerance, which is one of the important area, or one of the like as I told you, like we cannot move the quantum system without error correction mechanism, right? So that's why this is one of the important like the research area where you can concentrate on. If you come up with any novel error correction technique, then that will be useful for all the companies who are having the quantum computer and who are working on a quantum computation. So you can concentrate on this. Okay. And also one more area is quantum machine learning. So even we have discussed in detail about this also. You can even concentrate on that. And one more thing, as I told you, there will be quantum materials. So which is nothing but qubit research and development, we can call it as, where we are completely researching on qubit material, and also we will just do the research on qubit characteristics. So there, like we have the different materials, like we have the superconducting circuits, trapped ions, and topological qubits, and silicon based. So you can work on any of this, and you can even find the characteristic of a qubit from different materials. So this is where you can concentrate on. And apart from that, you can also concentrate on quantum software and hardware. So there is, like as I told you, we have the simulators, right? So there are very many quantum simulators are available. Like the even IBM is having QSKIT simulator, like QSKIT software. And similarly, we have Classic, and even our Indian government, they have been developed QUniverse. Okay, even in QUniverse also we can simulate it. So even you can concentrate on developing any quantum software also. And also, if you are interested, you can develop the quantum hardware also. Because when I was saying about secure communication, so if you wanted to transfer the data from one place to another place, you need the hardware, because we need to develop the quantum channel. All this will be associated with the hardware equipment, right? So if you are interested, you can also concentrate on developing the cost efficient and also like effective hardware development for the various quantum applications. And apart from that, you can also concentrate on hybrid quantum systems, where you can combine classical and hybrid systems to perform operations on various applications. So these are the research areas, like few research areas which have been almost like represented here. But apart from that, there is a lot of scope in quantum research now. Even like everyone are working in quantum, like now everyone are showing interest in quantum. So there will be a lot of opportunity in future also. So you can even try starting your journey in any of this research area. And apart from that, we also have the various quantum like research funding opportunities. I think if you are aware of, like in 2023, central government has been announced 6,006 crores for quantum research. So that we are calling it as a national quantum mission. So it has been announced in 2023 with 6,006 crores. So now, like, even government is giving that much of fund for the only quantum research. So that's why the research in quantum has been increased. Even people started working on it. That's why we have like a lot of startups came in these two years. And also there are a lot of project calls from the MIT and from the DST, even ANRF. So there are various like government funding agencies. A lot of project calls they are giving in quantum, especially in quantum research. So just try visit like DST portals and NRF portal and even MIT and all. So whenever you'll get a project call on quantum technology, then you can try applying to that. Okay. And apart from that, like as I told you, there will be a lot of project calls from the government of India and also from DST on collaboration projects. So they are showing interest in collaborating with the academia. So where they are developing the projects, and even they are also calling for the project submissions, like proposal submissions for the quantum applications, especially. ISRO is working on quantum key distribution and quantum communication. Even DRDO also working on that. So even every year, like ISRO is giving call for the proposal submission. So I think I mean, this year also we had a call from them. So if any of you are interested, so mostly ISRO calls are in quantum key distribution. So if any of you are interested in that particular area and also working in that particular area, you try applying proposals to those. Like if you have a strong research is like in quantum technology, then there is a lot of possibility. Various foreign universities and IITs and NITs also calling for the collaborations. So even if you like, as I told you, even IITs and NITs are also having a lot of quantum projects. So for that also they are giving opportunities for the academia for the collaboration, and also foreign universities, like various foreign universities they are working on quantum. So even you try collaborating with them and you can even contribute for their projects. And apart from that, you can also try for the industry collaborations. So even like good. So even as I told you, if you are interested in QPI AI and QNO Labs and other quantum startups, you can try collaborating with them and try to do the collaborative projects. And also we have other collaboration opportunities between Indo and foreign academia. So like as foreign universities we have, but nowadays we are getting the call saying that Indo German project call, Indo Italy project call. So India with other foreign countries, and like based on the name, there are like in recent years we have like recent days we have been seeing a lot of project calls accordingly. So if you know anyone from any country, if any call along with that country, with our country will come, or the notification will come from any funding agency, then you can try applying along with that particular person who's working in that particular like in your area or in quantum area in that particular college. So these are various funding opportunities. Those are I mean funding opportunities you will be having. And apart from this, even like many colleges currently working on quantum computing, so even you can have a collaboration with the other colleges also to continue your research in this particular area. Okay, and also at present there is a lot of opportunities for the MS and also for the PhD, and they are even foreign universities are offering very good fellowship for MS and also PhD in quantum technology. Like if you do the research in quantum computing and technology, you will get a very good fellowship at present. And these are some quantum computing, like quantum companies which are working worldwide. So few company names have been included, but in last 2 years there will be a lot of increase in like there is a lot of startup companies have introduced and they have been started, and like this is let us say some 10% of companies which are working worldwide, but apart from that we have a lot many companies which are working on quantum computing especially. Okay, so there are various applications. So if you are if you see, so few companies are working on superconducting. So these companies are working on superconducting materials, and these are working on cryogenic, and these are Intel and all working on the silicon, and the Psi Quantum and Xenon they are working on photon based. And there are other companies which are working on the combinational materials and all. And also there are various applications. If you want to know the companies which are working on finance, then you can concentrate on this. Similarly, these companies are working on material science, and there are some companies which are working on various areas of quantum computing. So these are some companies like worldwide, like which are doing good in quantum research, and also they are giving outcome related to the quantum, and which will be helpful for the society. And even if you are interested, you can try collaborating with any of this company, or you can even like try to collaborate with the industry, like academia also. Okay, so now if we talk about the challenges and limitations, so as we discussed earlier also, there are at present, like we have lot many advantages with the quantum technology. At the same time, there are many challenges and also the limitations. The first limitation we have is hardware limitation, because the current quantum systems are, like as I told you, will be associated with the noise, and even the hardware whatever we are developing will be of high cost. Okay, and at the same time, whenever we are whenever we are transmitting the data qubits to the hardware, like if we talk about the either channel, quantum channel or anything, it has to interact with the external environment. That leads to the noise, again that leads to the error. So with that, the current hardware will be having high error rate. So this is giving some restrictions when we apply it on practical applications, because due to this error, even though the mathematical it is giving 100% accurate, like 100% accurate result, but when you run it in real quantum system, it may not be 100% due to all these restrictions or internal noise. So that is major limitation now. So where even this limitation, you can also convert it into a research opportunity. So even you can try developing a hardware which can less prone to the noise. So even you can try that way. And second challenge is scalability. So at present we need to work on the fault tolerant quantum computers. So that is a little bit challenge now, because I mean even error correction all these are a little bit challenging. And then the one more challenge is coherence. So like coherence, as I told you, if I wanted to perform the operations on a qubit, it has to live for the longer time. So if it want to live for the longer time, then it has to maintain the coherence, right? So that Hilbert space we had, right? So we discussed in the previous session. So in Hilbert space, a quantum state will be represented. So if I wanted to measure, or if I wanted to perform the operations on this qubit, then it has to be in this particular Hilbert space. If it is come out of that Hilbert space, then whatever have been stored will be lost. So that we'll call it as a decoherence. Okay, so this coherence will leads to the lifetime. So if this is less, then automatically lifetime will be reduces. So that again a problem to perform an operation. And apart from that, one more like challenge is internal noise. So at present, we need noise mitigation techniques to reduce the internal noise. Okay. So you already know like why we'll get the noise. So this is due to the behavior of a photon particle. Whenever it interacts with the external environment, then it will leads to the noise. Okay. And the other challenge here we have is algorithm development. So where if I want to develop any real world algorithm, then it is difficult, because we will see the data in classical perspective. And if I wanted to convert it into quantum perspective, I need to apply quantum principles. So that is not easy. So it will be little complex, as we are discussing. That is what simply we are saying in words. Okay, when you apply it practically, then you will see the problems associated with it. So it is complex, but if you develop any algorithm accordingly, then it will be a novelty. Like even that is an innovation. Even you can like you can continue your work in that particular way. Okay. And one more thing here, the major challenge we have is cost. So as I told you, the quantum hardware is associated with the cost. So if I wanted to develop any quantum, for example, if we talk about So if we wanted to purchase any quantum system, for example, if we wanted to purchase, like if we wanted to perform operations on real quantum system, so actually we have to purchase this from the foreign countries. So most of the foreign countries are giving, even a few Indian startups also started working on it. So usually 2 qubit system or 3 qubit system usually cost around 1 crore, nearly 1 crore. Okay. So like, and by spending 1 crore, we could able to purchase only 2 qubit or 3 qubit. So if you could able to perform operations at characteristic level, then we can do some research on that. But if you wanted to perform only computation part, then it will be not of next level. It will be helpful so that like with the hardware equipment, we can understand how qubits are generated and how we can perform the operations. But if you wanted to do your research in next level, then it will not be sufficient. Okay, so that's how the cost is like 2 qubit or 3 qubit only costs around 1 crore. But when you talk about 5 or 6 or like 10 qubits, if you increase the number of qubits, then automatically cost increases. But if the number of qubits are more, then only you can perform more operations. Like you can apply it on various applications, because now we will be having applications with the huge data, right? So if I wanted to process that huge data, I need a larger number of qubits, right? So for that, again, like if the number of qubits increases, automatically cost increases, because when number of qubits increases, to connect all those, we need to like the hardware, everything will be associated with this. Like even hardware equipment, everything will be increases, right? So due to that, even cost also increases. So at present, one option we have is using cloud access. So this cloud access also we can use for the computation, purely computation like cryptography applications. But when we talk about quantum machine learning and all, if the runtime is in minutes or something, then the cost is again huge. Okay, so you need to like these are a current challenges we are facing, and also some limitations for which you can even come across with the solutions. Like even if you are like, if you consider this as a, instead of considering this as a challenge, if you consider this as a research possibilities, then you can even concentrate on developing a scalable quantum computer and cost-effective hardware development, and also you can concentrate on coherence time increase, like increase in coherence time. That leads to the quantum memories. So even we can concentrate on actually quantum memories at present. Okay, so what I'll explain next slide. So this is where you can concentrate on. And then these are the future directions where you can look into. So the first one, so as I told you, whatever the challenges we have at present, challenges or limitation, that we can convert into research possibility, right? Research opportunity. So one opportunity is quantum hardware advancement. So where you can develop the quantum hardware with the low cost and also with the high performance. Okay, you can even concentrate on that. At present, if you wanted to perform operations on quantum, if you wanted to do the quantum communication, you try develop the hardware equipment where you can transmit the data. Like physically, you can transmit the qubits from one place to another place. So for that, you need at the sender side, you need the laser beam or light beam, and also you need the polarization particles, and that you need to transmit through the quantum channel. So you need the quantum channel, you need to develop a quantum channel, so that must be effective, so that when you transmit the qubits through this, it should not make much noise, or it should not generate much noise. And also you need to develop the polarization particles and also laser beam. So when you develop all these things, if you could able to develop an equipment with less cost and also with high efficiency, like high efficiency when you transmit. Okay, at receiver side also you need to use the polarization particles, and also it has to measure the data. So this equipment usually a cost high, because we need many internal hardware devices associated with this. So if you could able to develop an cost effective hardware for such kind of operations, then it will be one of the novelty and also one of the advantage, or as we talk about in terms of research, then it will be one of the innovation. Okay. And then you can also concentrate on new algorithm designing. So new algorithms for error correction or fault tolerance, quantum computer, or even new algorithms for the quantum key distribution. So when you do the quantum key distribution in this way, there will be a lot of challenges associated with this. So to overcome that, if you come across with the new algorithm where you can transmit the data effectively with less cost and also with less equipment, then that will also be a novel algorithm. And also you can concentrate on error correction, and also you can concentrate on quantum memories. So, but the problem with quantum memories at present is coherence time, because the lifetime of a qubit is less, as I told you. So, for example, if you wanted to develop the memory, let us say this is a memory. If you wanted to store the data in the memory, it has to stay for longer time. So, in classical, when we talk about the memories, the data will be stored here until we delete, it will be as it is. So, the lifetime is almost like until you delete, right? But in quantum, it is not like that. Data can be stored for a specific time, because until it measure the like until it has the coherence with the other quantum states in that Hilbert space, it can live. Otherwise, it will be died. Like the data which we have been stored in that will be lost. So to develop the quantum memories, we need to first develop or increase the lifetime of a qubit, right? So that can be, I mean, if you could able to do that, then you can even concentrate on quantum memories. So even on this also research work is going on. So if any of you are interested, you can even concentrate on this. And the other thing is error correction. So at present, error correction is one of the important area, because as I told you, a system cannot be like, even quantum system cannot be developed or cannot be imagined without error correction, because by default a quantum system will be having the noise, and that will leads to the error. So the error rate of current quantum systems are high. So if you could able to reduce that by using any error correction mechanism, then it will be a very important in current scenario. And also in error correction, again, there will be a lot of challenges. So because in error, when you do the error correction, you need to detect the errors which are of bit mod, like which are bit flip, phase flip, or both also. So as I told you, finding or detecting and correcting bit flip will be not, I mean, little bit okay, but when you do the phase detection and correction, no, it will be little bit challenging, because as I told you, in output we will not get the phase detection when you see it in the graph representation, but when you see it in Hilbert space representation, you will see how phase has been modified. So in that case, you need to calculate the probability in terms of a number of, like in terms of bits and also in terms of phases. Okay. So that's why it is a little challenging, but also very interesting area where you can concentrate on. So like even my research area is a quantum error correction. I worked on quantum key distribution also. So even like even when we start, we may feel difficult, but later on, once you start working in that particular area, then the work will be like you will get interest, and automatically you will get to know. I mean, will be more interested to know many other things, like how it will work and how that particular error will be detected and corrected. So you get a lot of ideas. You try applying those ideas in, and any one of the idea may work, right? So you can concentrate on that. And the other is hybrid models, where you can combine classical and quantum models. So currently we are working with the hybrid models. Example is quantum machine learning, where we are combining quantum machine learning and classical machine learning. Because as I told you, for post processing in quantum machine learning, you need to use quantum classical machine learning models only. So that can be done using the hybrid model. Like I mean, that is where you can concentrate on. So where you can combine both classical and quantum like models. Okay. And apart from that, you can also concentrate on broader applications, like which are complex at present, like climate prediction. Like even you can also concentrate on uh, radar applications. Like if you wanted to combine satellites or radar communication, you can also concentrate on that. So which are very rare areas. Not much people are started working in that. You can even concentrate on those. And also one of the important direction you can concentrate is standardization frameworks. So if you could able to develop any a new standardization for any quantum model, then you can, I mean, even you can show that as a novelty, and also you can go for the patent filing and also for the publications also. Okay. So these are the various future directions where you can concentrate on. But apart from this, there are many other areas, as I told you. If you are interested in quantum materials, you can start working on quantum materials. So the people who are aware of materials like nanomaterials and like nanomaterials, usually electronics people will learn about materials and all. No? So if you are interested in that, you can concentrate on quantum materials. So there is lot of research opportunities. I mean, even funding opportunities are available in quantum materials. And at the same time, even you can concentrate on quantum sensing, which completely depends on the qubit characterization. So these two will be works at qubit level, and computation and communication will be on qubit. Like we are not generating the qubit, but on generated qubit, we will be like generated qubits we will be using for a computation purpose and also for the communication purpose. Okay, so these are the various future directions we have and various opportunities we have where you can concentrate or where you can look into. And like apart from this, so any doubts here in future directions? Okay, so yeah, so like with this we have been like related to the discussion on or presentation various applications we have been completed along with future directions. So now after this we will be having one capstone assignment, right? So like this assignment have been given related to our previous classes. So I've been given based on the quantum machine learning class and also like session 2 and session 3. In noise and error mitigation, we have been discussed how to give manually, like how to give the noise to the gates manually. So that also have been included. And one more in quantum machine learning, we have seen how to develop the future space, like how to develop the quantum SVM by using rotational gates and also various entanglements, right? So those two will be your, like you can refer those two sessions for solving these capstone projects. So this will be like an assignment and also the project for like today's session. So the first question is develop and simulate a 3-qubit entanglement circuit using noise levels. So even like when I spoke about like even I've shown this on IBM QSkit platform. So on offline platform, I've shown you, even I've been executed this. So there I've been used only 2-qubit representation. So there I've been used one Hadamard gate and one CNOT gate. So we have two inputs in that. But here I'm asking you to apply it on 3 inputs. So then there will be one more CNOT gate on second and third qubit. Okay. So here manually you have to apply the errors on first gate, that is 0.08, and second gate 0.12, and on third gate 0.2. Okay, just same algorithm will be same, but the input will be changes and also the noise levels will changes. So accordingly, you have to simulate it and you have to see what the output is. Okay. And the second project is on develop and simulate 4-qubit QSVM circuit using rotational gates and also circular entanglement. Okay. So 4-qubit SVM is like we have the 4 inputs. So we have been discussed about 2-qubit, I think 2-qubit or 3-qubit SVM. 2-qubit structure have been explained and 3-qubit circuit have been shown in quantum neural networks. So now you have to on 4-qubit. Okay, so here first you have to apply the rotational gates on 4 qubits and then you have to apply the entanglement. So to make the correlation between all this, you need to develop the entanglement. So here I'm asking you to use the develop the circular entanglement. So even in that also, I've told you about the different entanglements, right? There is a linear entanglement, circular entanglement, and full entanglement. In circular entanglement, you will do the entanglement between first two, 1 and 2, 2 and 3, and 3 and 4, and again from 4 and 1. Okay, these are all CNOT gates. So this is how a circular entanglement will be done. So this is about the rotational gates. So the structure is same. You need to develop this in quantum platform. Okay. And then the third one is develop a noise aware QSVM circuit and compare classification accuracy before and after error mitigation. So this is a combination of these two. So when you combine these two, so in first we are noise aware simulation we are doing, and here we are developing the QSVM. Now you combine these two. So in QSVM, when you develop it, you need to apply the noises on each gate. 1, 2, 3, 4 gates we have, right? So on each gate, just apply the noise. Your that's your wish. Like you can apply any noise. You can be applying either 0.001 or anything. You can take any noise level. And same program, whatever we have been discussed in this noise mitigation, instead of entanglement circuit, you have to use the QSVM circuit and add the noise accordingly and see what could be the output. So these are 3 capstone projects have been given as a project and also as an assignment. So if you work on this, then you'll get the clarity. Okay. For the reference for these questions and for the implementation, go through our session 2 and session 3, which we have done day before yesterday and before that. Okay. The project has given in very simpler way. If you could able to do this, then it will be helpful for you to understand the next level concepts in quantum machine learning, and also you can start working in that particular quantum machine learning. Okay. So that's all about today's presentation. Okay. Thank you. And these are my contact details. If any of you are interested to do the thing, because many of you are asked in our last session, so you can either connect me through this mail ID or you can connect me through LinkedIn. So my LinkedIn profile name will be Dr. Swati Mumadi. You can, in my profile pic will be there. So you can even connect me through that so that you can see the updates on my work in quantum technology. Yeah. Any queries? Hello. Hello.
Participants, you have any queries?
If you want, you can also type in chat box if you have any queries. Otherwise, you can ask directly. So once it is done, like after question and answering session, there will be a quiz that will be conducted by the coordinators, like organizers. And then they will be like, I will be sharing this capstone project questions with you all, and you have to solve those. So if you have any doubts related to anything till now, like whatever we have been discussed in last 4 sessions, like we have been discussed on basics and then quantum noise mitigation and error correction, and then we discussed on quantum machine learning along with the various machine learning algorithms, and today we discussed in detail about various applications of quantum and its like research and future perspectives of that. Yeah. Any doubts? Okay. Yeah, you can ask if any doubts. Otherwise, Anvita ma'am?
Ma'am.
Yeah, if there are no doubts, then we can wind up so that they can do their quiz. And then they can submit the capstone project. You can give some deadline for that.
Yes, ma'am. Sure, ma'am.
Yeah, you can give some deadline. So maybe tomorrow holiday, right? Sunday. So you can give till tomorrow evening, because all those are very basic level of projects have been given. And for that reference, we have in detail in session 2 and session 3. Already, I think you have been sharing the videos, right? Session
Yes,
videos.
ma'am. Yes, ma'am.
Yeah, so they can go through that video, because even in programming, like even in the QSkit platform, and it's yeah.
Excuse me, ma'am.
Yeah, sir. Tell me.
Ma'am, what are the various open source tools? Do we have any open source tools available to simulate quantum computing environment?
Yes, sir. Yeah. Open source we have. So one is IBM, which have been shown with the
Apart from
practical implementation. Yeah, apart from IBM, we have Classic. I think that also they are giving drag and drop, and even lab level they are giving. And also we have Q-Inverse. Q-Inverse, like it is developed by our government. So it is under MIT. So that also you can look into, sir.
Okay, ma'am. Thank you.
Yeah.
Ma'am, I have a doubt.
Yeah, sir. Tell me, sir.
Will the existing cloud infrastructure be able to support quantum computing, ma'am? Will it be able to scale to that extent?
Existing, what's it? Existing?
The cloud infrastructure.
Yeah,
Cloud
yeah.
infrastructure as service can we use for quantum computing? Will it be possible?
Yeah, for quantum, we have a quantum cloud, sir. You can make use of that because, if you wanted to work with the quantum experiments or if you want to run and simulate, we need the quantum environment. So that will be supported by the quantum cloud, which is available, sir. It is available.
Is it a subscription model, ma'am? As a paid model, I
Yes,
think.
yes. Yeah, actually, a cloud is paid model. As I told you, actually, when I started working in quantum in 2018, we had a free access given by the IBM. But later on in the year of 2024, they made it as pay and use. Even not only if you talk about AWS, that also pay and use. So you may have to pay some $1.5 nearly for 1 second runtime. So that's why for the machine learning applications, it may take a lot of time. So it will be associated with the cost also when you run it on real real quantum system. But those are available. But as you said, it is like associated with the cost.
Okay, thank you. Thank you.
Yeah. Oh.
Well, we have been taking exams the last few days also. After every session, exams are given.
Mm-hmm.
So we were submitting. I think this is another exam for the last session, right, ma'am?
No, this is related to today's session. It's completely on applications.
Yes, ma'am. Yes, ma'am. Earlier we have already taken the exams, ma'am, for machine learning
Yes,
and all
yes.
that.
Correct. After completion of every session, that session related content has been given as a questions and quiz. So similarly, for today's exam also, the content what we discussed in today's session will be given as a quiz. But this capstone project is a combination of all these sessions, like what you have been learned, like in last 4 sessions. So combinedly, we have been given it as a project.
Okay, ma'am. Okay. Thank you, ma'am. Thank you.
Okay, sir.
Hello, ma'am.
Yeah. Hi, ma'am.
Hello, ma'am. Good evening. Ma'am, actually, as technology is growing up, so in the learning process, what I thought is I want to teach this computer architecture course. So could you please tell me how we are going to integrate quantum computing concept into computer architecture course, ma'am?
Computer architecture is completely different, ma'am. As I told you, like at present, whatever the computers have been developed, those will support only classical data, 0 and 1. Accordingly, we have improvement, right? But quantum is completely different. We need some quantum architecture concept. In that case, you need to talk about the polarizers because those polarizers and all will not talk in classical computer architecture, right? So you need to change the syllabus according to quantum information.
Okay.
So there you can see that the future technology like quantum, but you cannot correlate you cannot compare the equipment like what we are discussing in memories. We have cache memory, virtual memory, all these things, right? But in quantum, we don't have all those concepts. It is completely different computer. So you need to talk about complete different terminology and different information, and you need to include completely different concepts. I think if you are working in if your college is under JNTU and OU, I think they have been made it mandatory to learn quantum computing in first year of I think second semester, first year, second semester. They included it in advanced physics. So quantum computing subject is there, and there they will learn basics, all basics. Almost they have been included till algorithms.
But
So
somewhere I studied about if we want to integrate, we can integrate this quantum computing in this computer architecture. So that is why I am
quantum
asking.
computing. No, if you want, because in my first slide itself, I've shown you like our computer architecture is based on one human architecture. Quantum is not one human, it is completely different. So that's why I'm saying that.
Okay,
So,
okay.
I mean, you can integrate because we are currently working with the quantum cloud, with the help of classical computer only, but entire processing is done, will be happening at quantum processing unit, which is not like, which is in like cloud access we are using. So
Okay.
to work on quantum, at present we don't have universal quantum system, so that we are taking the help of classical. So it will be
Okay.
like to give the inputs and all, we are using it, but entire, if you talk about the processing and all, no, then that entire architecture is different. I think they would have told about this correlation, like how we are using classical computer to work with the quantum. So that you can say, that you can talk about, but if you wanted to talk about only the quantum computation and quantum information, then that is completely different.
Okay, ma'am. Thank you.
Okay. Yeah. Any other doubts? I'll share the capstone project titles, the data with the organizers. They'll share with you in. You will be having. You will be having a WhatsApp group. No, they'll share it in that. But meanwhile, if you want, I can share it here also. So I'm messaging here. You can go through this, but no need to worry. I'll share it with the organizers. They'll share it with you. Okay. Any other doubts? Please concentrate on the project which has been given. It is not a like difficult project or not a completely new project. We have been discussed those in previous slides or previous sessions. Try to again go through those sessions and see how we have done there and what you have to do for the what you have to do for completing those projects. Okay. Yeah. Okay, Anvita ma'am. Then I think there are no questions. Can we wind up?
Yes, ma'am. Please stay back for 10 minutes. Rajkumar sir and HOD sir also joined us for the validatory function, and we are requesting you also join with us for the validatory session, ma'am.
Yeah, Krishna Pure, ma'am.
Sure.
I already
Sure,
joined.
sure.
Let us start. Do not waste madam time. Yeah.
Yeah, yes, sir. Thank you so much, ma'am. And I'm myself Krishna Priya, and I'm one of the coordinator for this professional development program. A very good evening to one and all. With great pleasure, I welcome you all for the validatory session of our 5-day national level professional development program on quantum computing, organized by the Department of CSC, Cybersecurity, Data Science, and Artificial Intelligence and Data Science, VNRVJIET, in association with Blackbucks Educational Private Limited. Over the past few days, we had an incredible journey of learning and by exploring the fundamental concepts of quantum computing and quantum machine learning and quantum Fourier transformation and real world applications and what are all the opportunities we have and which will help us towards our career like this from the eminent resource persons. Today, as we bring this enriching program to the close, we take this opportunity to express our gratitude and sharing of reflections and celebrate the successful completion of this academic endeavor. Before we conclude the today's session with the vote of thanks, we kindly request the participants to take a moment to share their valuable feedback with us so that it will help us to improve and plan more effective programs in future also. Participants, mute yourself and share your suggestions and feedback, and it might help us. It will make us very encouragement or as well as for future improvements also. Participants, over to you. Please give your valuable feedback and suggestions about this 5 days professional development program. Anyone want to share anything? Please feel free to express yourself. Okay. Thank you so much, all. And Now, as a part of Validity session, we are privileged to have our industry collaborator, Mr. Rajkumar sir also, who is the Director of Growth and Partnership, Blackbucks Educational Private Limited with us. I would now like to invite Rajkumar sir to share a few words and his reflections on this 5 days program, sir. Sir, over to you.
Well, thank you so much, Krishnapriya ma'am. Well, for all the participants and the last day of quantum computing PDP session, professional development. On behalf of Blackbucks, I extend my heartfelt gratitude to the uh, VNRVJIET institution and organizing impactful professional development program. And we could see there is a lot of intention of a college to make this event successful, and they are been following from last 1 month, because this where college as a service, they want to share the knowledge to all the faculties across the place wherever they are. So I really share my heartful gratitude to entire institution management, especially to HOD and Professor Sir Dr. Sunil Kumar sir for making this possible. Without you, it is not possible. And thank you so much for all the coordinators, Priya ma'am, Dr. Sunanda ma'am, and Dr. Pramod Garu for making this end-to-end coordination with all kind of support. And our Blackbucks team is trying to post whatever the information that can be possible from our side to all the participants. As everybody knows, is always news. So we request you to please there in the WhatsApp group as an industry partner, when we are bridge between industry side of requirements and college funding. We keep posting the resource materials in the WhatsApp group. So please stay in the WhatsApp group. Don't leave after the certificates. We wanted to share some kind of Monica, my voice is clear?
Yes, sir, but little bit lower.
Ma'am, is it clear, ma'am, right now?
No, sir.
Hello. It's not clear, ma'am?
It is clear, sir, but low, little bit lower than the.
Is it clear, right? 1 second. Sorry, excuse me. I'll just a moment then. So, I'm sorry, Janeb. Just give me one time, please. I'm sorry. Excuse me. I'm not sure why it is not getting.
I'm so sorry. If my voice is clear, can you please someone confirm? I'm sorry for the
Yes, sir.
disturbance.
Yes, sir. Now it is
Oh,
perfect.
I'm sorry. Uh, I'll just start where I stopped, ma'am, not to waste the audience time. So, just a special thank and heartful thanks to HOD sir and all the organizers in this entire PDP program, Krishna Priya ma'am, Sunanda ma'am, and Pramod sir. So, we request all the participants to be in the WhatsApp group. So, as an industry bridge between industry and academics, Blackbucks like to share all information about quantum computing all kind of resource materials and the kind of industry updates, we will be keep posting in the WhatsApp group. So please don't leave the WhatsApp group after the entire certification. Definitely, we'll be going to share any kind of information in the WhatsApp group. And also, if anyone is interested in terms of future FDPs or any kind of virtual labs in quantum computing, Blackbuck is here to support you in terms of taking it possible. And we request everyone to keep upgrading yourself as industry is growing. So, so you'll be the always first person that we will always believe that you can understand the knowledge what's happening in industry, and we are the Blackbucks will be standing for you and keep posting in the WhatsApp group. So thank you so much, all the organizers and VNRVJIET College for this opportunity. Over to you, ma'am.
Yes, sir. Thank you very much, sir, for your inspiring words and encouragements and creating this good platform where we can learn new things and exchange of knowledge from one end to another end. And now I would like to invite our convener and head of the department, Dr. Sunil Kumar, sir, to share his concluding remarks and message to all participants. Sir, over to you, sir, please. Sir, Sunil, sir. Sunil, sir, unmute yourself. Sunil, sir.
Yeah, Krishna Priya, ma'am, am I audible now?
Yes, sir. Yes, sir. You are audible.
Yeah. Thank you so much, ma'am. Sorry for the inconvenience because actually it was mute. All participants were muted by host. I was unable to unmute my mic for a while. No problem. Great. First of all, I am Dr. T. Sunil Kumar here. I am delighted to be part of this incredible, wonderful journey for the last 1 week, hosted by our department, CSC, having 3 specializations, cybersecurity, data science, and AIDS, in the prestigious institution, which has been working and striving hard to serve the society under the service motto of not-for-profit organization, VNRVJIET Institute of Engineering and Technology, Hyderabad, Telangana. We are all privileged to be part of such a wonderful institution. This particular event, quantum computing, a professional 5-day national level professional development program, has been hosted by our department in association with our associate and partner institution, Blackbucks Educational Private Limited, especially with the help of Mr. Rajkumar sir, Purnagiri, who is kind enough accepting our request and supported unwaveringly. And today that has been possible because of his support. Thanks for that, Sir Rajkumar sir. And I'm also delighted to express my special thanks to our eminent intellectual resource persons, Dr. Swati Ma'am Ummadi, who is a research fellow at Unimap, Malaysia, and also Dr. P. Venkat Subbareddy sir, who is a senior faculty, Computer Science Department, NIT Warangal. Both of them have really done a wonderful service, deliberated an excellent content and done insights about our new a groundbreaking latest thrust area, that is none other than quantum computing, where everybody is really striving hard for really bringing that, made it possible for all the people to reach and get motivation, especially people like us have been working with academia, industry, and also research organizations. I take this online platform once again to thank all those background innovative minds and visionary leadership everywhere from the world. And especially I also take this platform once again to really personally express my heartfelt thanks always to these online tools providers who has been really kind enough and encouraging us to have such a facility, though physically we are all separated, geographically spread across respective of zones, time, and then sessions day and night. But we are all actively engaged in learning, especially as the learning is the lifelong learning responsibility. And one of the prime objective of our faculty, that's lifelong learning. So we are all delighted to have such wonderful online platforms. Special thanks to all those providers. And especially, again, I take once again this platform to express my heartfelt gratitude for our visionary management, high-end leadership of Vignan Jyoti Society, visionary management, and also our beloved principal, Sir Dr. C.D. Naidu garu, and our Director Advancement and Dean Finance and Administration, Dr. Bhishan Nakeshwara garu, all the other deans and heads of the departments and all senior colleagues. And many congratulations to our young and dynamic team of all three organizations, Mrs. Krishna Priya ma'am, Dr. Sunanda ma'am, and Dr. Pramod Kumar sir, for their interest, enthusiasm, and scrupulous planning to materialize this, and then been implemented this for last 1 week, and successfully we have reached at end of the session more or less, and we are going to complete very soon. Many congratulations to the entire team for their unwavering support and selfless planning and executing this event. I wish them a good luck, and also I request them to continue such wonderful latest areas. FDPs, especially these professional development programs, are the key for us to have an association and networking with all other colleagues across the globe. And also the enthusiastic learners and researchers, faculty, and industry personnel who believed with us and joined the overwhelming number of 800 and almost nearer to 900, 880 plus registrations. Around more or less every day, 200 to 300 people have networked and joined online using these online platforms. And we had a seamless sessions, and resource persons have wonderfully delivered all the contents, and then they gave us the best insights. My only request as the head of the department is that all the people who have joined with us and registered for this, please continue your networking with us. And we love to have you all over on our WhatsApp group, as already been requested by our Rajkumar Bonagari sir from the Blackbucks Educational Private Limited. Really let us have this as a starting point to continue our journey of learning. As a learning is nowadays one click away, but we have a wonderful people who have networked with us under this banner of PDPs. And I'm sure in the future, please, whenever you conduct such kind of events, please invite us. We love to have that kind of association with all higher end institutions and research organizations. And also as a head of the department, I have a department request once again here. Please permit me to put forward this request. Our organization is a wonderful organization serving to the society with not-profit motive. Please apply for our organization as and when notification releases for the faculty positions, researcher positions, any leadership positions. We want to have you on our campus. We know that under this PDP, we have noticed that many intellectual people, those who have a very good research profiles and high-end profiles, who has been working and serving the society and delivering their intellectual knowledge to the society. I know many people are associated with us now. I request all of you, please surf our website, especially our department, CSC, Data Science, Cyber Security, and DIDS. We have a 360 intake plus one specialized MTech program, that is latest area. MTech in Data Science, 18 intake. This year, we have that program in our Vignan Jyoti Crown as a new feather. That course has been approved, and we have been offering from this academic year 2025 to 26 academic year onwards. Please apply for all the relevant positions which you suits for. Definitely, we try to have you with us based on your credentials and qualifications and experiences. That's my personal department request. Sorry for the inconvenience. If anybody feel bad about it, permit me, because we are in need of that. So that's why I have taken liberty. Great. And accordingly, and I also take this last word on this platform to express my special thanks for all the people who really joined on this PDP with us. And I wish them a good luck to continue our learning. Thank you so much, everybody. Once again, congratulations to the organizers and everybody. These are the few remarks and my concluding remarks. And we'll wish to have such wonderful future associations with everybody who has joined with us. Thanks a lot. God bless you all and have a great weekend ahead. Take care of your health. God bless you all. Thank you so much, Krishna Pri ma'am. Over to you. Please continue.
Yes, sir. Thank you so much, sir, with all your encouragement, support, and everything. Because of that, today this program has been successfully completed, sir. And finally, as we conclude this enriching journey, let us carry forward the spirit of learning and collaboration that this PDP has instilled. May the knowledge gained here inspire and innovate your teaching skills and pursue the various research and future collaboration in the field of quantum computing also. I hope every participant has been gained a new knowledge and make it as an exercise and try to pursue your career towards the emerging technologies so that we will get an exposure also. Thank you once again to everyone who made this program as a resounding success, and thank you so much to the industry collaborators as well as the resource persons especially. And more or less, finally I just wanted to extend my thanks to our participants. Without participants it's not possible also. Thank you so much. Wishing you all continued learning and success ahead. Thank you all.
Thank you. Thank you so much.
Yes, sir.